Jupiter, the king of our solar system, reigns over a vast court of moons. Among them is Amalthea, a small inner moon that stands out for its vibrant red hue. Amalthea's irregular shape and battered surface tell a tale of cosmic collisions and gravitational tug-of-war. It orbits within a faint ring of dust and debris, a celestial ribbon constantly replenished by particles blasted off its surface. This ring, along with Amalthea's unique characteristics, makes it a target of intense scientific interest. Discovered in 1892, Amalthea was the first Jovian moon found after the 4 Galilean moons. Amalthea is tidally locked to Jupiter, meaning the same side always faces the planet, creating extreme conditions. Intense radiation bombards its surface, and tidal forces constantly squeeze and stretch its interior. By studying how its surface interacts with Jupiter's radiation, we can refine our understanding of planetary dynamics. Amalthea holds a wealth of information about the universe we inhabit. The year is 1892. At the Lick Observatory in California, astronomer Edward Emerson Barnard was engaged in routine observations of Jupiter. As he peered through the 36-inch refractor telescope, a faint speck of light caught his eye. It was close to Jupiter, too close to be any of the known moons. Intrigued, Barnard carefully tracked the object's movement over several nights. The object's rapid movement around Jupiter confirmed it was indeed a moon, a fifth satellite in Jupiter's growing family. This discovery sent ripples of excitement through the astronomical community. The discovery of a fifth moon, especially one so close to Jupiter, challenged existing theories about the formation and stability of planetary systems. Barnard's discovery was a testament to his observational skills and a reminder that our solar system still held secrets. The fifth moon of Jupiter became a focal point for astronomers eager to unravel its mysteries. The discovery of a new celestial object invariably leads to the question of what to call it. Among the proposals, one name resonated with particular strength: Amalthea, a nymph from Greek mythology. In Greek mythology, Amalthea played a pivotal role in the early life of Zeus, the king of the gods. According to legend, Rhea, Zeus's mother, hid the infant god in a cave on the island of Crete to protect him from his father, Cronus. Amalthea, a goat nymph, was entrusted with the care of the infant Zeus. She nurtured him with her goat's milk and protected him from harm. The name Amalthea, with its connotations of nurture and protection, seemed a fitting tribute to the newly discovered moon. The name served as a constant reminder of the rich tapestry of mythology and science that shapes our understanding of the universe. Amalthea's surface presents a scene of ancient violence and cosmic bombardment. Unlike the relatively smooth surfaces of some icy moons, Amalthea's face is heavily cratered. These craters are the result of countless impacts from asteroids, comets, and other debris. Each crater tells a story of a collision, a moment frozen in time. The sheer number and size of these craters paint a picture of a world that has been relentlessly bombarded. By studying the size, distribution, and degradation of Amalthea's craters, scientists can piece together a timeline of bombardment. One of the most striking features of Amalthea is its vibrant red hue. This distinctive coloration has earned Amalthea the title of the reddest object in the solar system. The exact cause of this intense redness is still a subject of scientific debate. One theory suggests that the red color comes from sulfur compounds deposited on Amalthea's surface. Another possibility is that the red color is due to the presence of organic molecules. These variations in color provide scientists with valuable clues about the processes that have shaped Amalthea's surface. Unlike many moons, Amalthea is distinctly irregular in form. Instead of a sphere, Amalthea resembles a lumpy potato or a cosmic brick. This elongated and irregular shape is a testament to the powerful tidal forces that have sculpted Amalthea. The ongoing tidal forces continue to knead and flex its interior, generating heat and potentially contributing to the moon's geological activity. The elongated shape of Amalthea also affects its rotation. Amalthea's orientation in space constantly changes, adding to its already dynamic and unpredictable nature. Scientists have been able to glean insights into Amalthea's makeup by studying its light spectrum and density. These observations suggest that Amalthea is not a solid, rocky body like the Earth's moon. Instead, it is thought to be a loosely bound agglomeration of rock and ice. The porous rubble pile structure of Amalthea has implications for its internal structure and evolution. The presence of water ice within Amalthea raises intriguing possibilities. The tidal forces from Jupiter generate heat within the moon, potentially melting some of the ice and creating subsurface pockets of liquid water. Amalthea's orbit is a marvel of celestial mechanics, a delicate balance between the inward pull of Jupiter's massive gravity and the outward force of the moon's own motion. Amalthea races around Jupiter at a breakneck pace, completing one orbit in just under 12 hours. This rapid orbital period is a direct consequence of Amalthea's close proximity to Jupiter. This close proximity to Jupiter also means that Amalthea's orbit is not perfectly circular, but slightly elliptical. Amalthea's rapid orbit and close proximity to Jupiter create a dynamic environment. These forces have shaped Amalthea's appearance, its internal structure, and even the very nature of its relationship with the giant planet it orbits. Amalthea's orbit lies deep within Jupiter's gravitational well. This close proximity means that Amalthea is affected by the variations in gravitational force across its diameter. This difference in gravitational pull creates tidal forces, stretching and squeezing Amalthea. The side facing Jupiter experiences a stronger gravitational pull than the side facing away, causing a bulge to form on the near side. This constant stretching and squeezing generate heat within Amalthea's interior, contributing to its geological activity. Tidal forces are a constant reminder of the powerful influence Jupiter exerts over its inner moon. Amalthea's orbit lies within a faint ring of dust and debris known as the Amalthea Gossamer Ring. This tenuous ring, invisible to the naked eye, is a testament to the ongoing interplay between Amalthea and its surroundings. Imagine a cosmic halo composed of countless tiny particles encircling Jupiter and tracing Amalthea's orbital path. This ring, while seemingly insignificant compared to Jupiter's majestic ring system, holds valuable clues about Amalthea's history and the processes that shape planetary systems. The Amalthea Gossamer Ring is composed primarily of dust and debris ejected from Amalthea's surface. As meteoroids and other small objects collide with Amalthea, they blast off material at high speeds. These ejected particles, ranging in size from tiny grains to larger boulders, form a tenuous cloud around Amalthea's orbit. Over time, this cloud spreads out, forming the faint ring we observe today. The Amalthea Gossamer Ring is incredibly faint, reflecting only a tiny fraction of the sunlight that falls upon it. This faintness is due to the small size of the particles that make it up and their low density. Despite its tenuous nature, the Amalthea Gossamer Ring plays a crucial role in understanding the dynamics of the Jovian system. By studying the ring's structure, composition, and evolution, scientists can learn about the processes that shape planetary rings, the history of impacts in the Jovian system, and the interaction between Amalthea and Jupiter's powerful magnetic field. The Amalthea Gossamer Ring, though faint and often overlooked, serves as a reminder that even the smallest celestial objects can have a profound impact on their surroundings. Amalthea's orbit lies within a faint ring of dust and debris known as the Amalthea Gossamer Ring. This tenuous ring, invisible to the naked eye, is a testament to the ongoing interplay between Amalthea and its surroundings. Imagine a cosmic halo, composed of countless tiny particles, encircling Jupiter and tracing Amalthea's orbital path. This ring, while seemingly insignificant compared to Jupiter's majestic ring system, holds valuable clues about Amalthea's history and the processes that shape planetary systems. The Amalthea Gossamer Ring is composed primarily of dust and debris ejected from Amalthea's surface. As meteoroids and other small objects collide with Amalthea, they blast off material at high speeds. These ejected particles, ranging in size from tiny grains to larger boulders, form a tenuous cloud around Amalthea's orbit. Over time, this cloud spreads out, forming the faint ring we observe today. The Amalthea Gossamer Ring is incredibly faint, reflecting only a tiny fraction of the sunlight that falls upon it. This faintness is due to the small size of the particles that make it up and their low density. Despite its tenuous nature, the Amalthea Gossamer Ring plays a crucial role in understanding the dynamics of the Jovian system. By studying the ring's structure, composition, and evolution, scientists can learn about the processes that shape planetary rings, the history of impacts in the Jovian system, and the interaction between Amalthea and Jupiter's powerful magnetic field. The Amalthea Gossamer Ring, though faint and often overlooked, serves as a reminder that even the smallest celestial objects can have a profound impact on their surroundings. Amalthea's orbit lies within a faint ring of dust and debris known as the Amalthea Gossamer Ring. This tenuous ring, invisible to the naked eye, is a testament to the ongoing interplay between Amalthea and its surroundings. Imagine a cosmic halo, composed of countless tiny particles, encircling Jupiter and tracing Amalthea's orbital path. This ring, while seemingly insignificant compared to Jupiter's majestic ring system, holds valuable clues about Amalthea's history and the processes that shape planetary systems. The Amalthea Gossamer Ring is composed primarily of dust and debris ejected from Amalthea's surface. As meteoroids and other small objects collide with Amalthea, they blast off material at high speeds. These ejected particles, ranging in size from tiny grains to larger boulders, form a tenuous cloud around Amalthea's orbit. Over time, this cloud spreads out, forming the faint ring we observe today. The Amalthea Gossamer Ring is incredibly faint, reflecting only a tiny fraction of the sunlight that falls upon it. This faintness is due to the small size of the particles that make it up and their low density. Despite its tenuous nature, the Amalthea Gossamer Ring plays a crucial role in understanding the dynamics of the Jovian system. By studying the ring's structure, composition, and evolution, scientists can learn about the processes that shape planetary rings, the history of impacts in the Jovian system, and the interaction between Amalthea and Jupiter's powerful magnetic field. The Amalthea Gossamer Ring, though faint and often overlooked, serves as a reminder that even the smallest celestial objects can have a profound impact on their surroundings. Amalthea's orbit lies within a faint ring of dust and debris known as the Amalthea Gossamer Ring. This tenuous ring, invisible to the naked eye, is a testament to the ongoing interplay between Amalthea and its surroundings. Imagine a cosmic halo, composed of countless tiny particles, encircling Jupiter and tracing Amalthea's orbital path. This ring, while seemingly insignificant compared to Jupiter's majestic ring system, holds valuable clues about Amalthea's history and the processes that shape planetary systems. The Amalthea Gossamer Ring is composed primarily of dust and debris ejected from Amalthea's surface. As meteoroids and other small objects collide with Amalthea, they blast off material at high speeds. These ejected particles, ranging in size from tiny grains to larger boulders, form a tenuous cloud around Amalthea's orbit. Over time, this cloud spreads out, forming the faint ring we observe today. The Amalthea Gossamer Ring is incredibly faint, reflecting only a tiny fraction of the sunlight that falls upon it. This faintness is due to the small size of the particles that make it up and their low density. Despite its tenuous nature, The Amalthea Gossamer Ring plays a crucial role in understanding the dynamics of the Jovian system. Section 4. A beacon in Jupiter's magnetic field. Amalthea orbits within Jupiter's magnetosphere, a vast region dominated by the planet's powerful magnetic field. This field, generated by swirling metallic hydrogen, acts as a shield, deflecting solar wind. Imagine a cosmic bubble, protecting Jupiter and its moons from space radiation. Amalthea channels electric currents, creating a secondary magnetic field. This field interacts with plasma, creating an auroral footprint in Jupiter's atmosphere. Amalthea's auroral footprint reveals its presence and interaction with Jupiter's magnetosphere. Scientists study this emission to learn about Jupiter's magnetic field and Amalthea's conductivity. Amalthea's presence subjects it to intense radiation, altering its surface. This interaction highlights the dynamic nature of planetary systems. Even small objects like Amalthea play significant roles in these systems. Section 1. A window into Jupiter's formation. Amalthea, despite its small size and seemingly insignificant nature, holds valuable clues to the formation and evolution of Jupiter and its moon system. Imagine a time capsule, preserving remnants of the early solar system, a time when planets were forming and chaos reigned. Amalthea, with its ancient surface and primordial composition, provides a unique window into this tumultuous period. Scientists believe that Jupiter, like other gas giants, formed through a process of core accretion, where a massive core of rock and ice gradually accumulated gas from the surrounding protoplanetary disk. As Jupiter grew in size and mass, its gravitational influence sculpted the surrounding material, forming a circumplanetary disk from which its moons coalesced. Amalthea's composition, a mixture of rock and ice, suggests that it formed in the colder outer regions of Jupiter's circumplanetary disk, where water ice could condense. The moon's irregular shape and heavily cratered surface indicate that it has experienced a violent history of collisions, a testament to the chaotic conditions that prevailed during the early stages of planetary system formation. By studying Amalthea's composition, structure, and orbital dynamics, scientists can gain insights into the composition of Jupiter's circumplanetary disk, the processes that governed moon formation, and the role of collisions in shaping planetary systems. Amalthea, though small, provides a valuable link to the early solar system, helping us to understand the events that led to the formation of Jupiter and its diverse collection of moons. Section 2. Probing the secrets of tidal heating. Amalthea's close proximity to Jupiter subjects it to intense tidal forces, a consequence of the varying gravitational pull across its diameter. These tidal forces, like an invisible hand constantly squeezing and stretching the moon, generate heat within its interior through a process known as tidal heating. Imagine a cosmic hot water bottle, constantly being kneaded and flexed, releasing heat into its surroundings. Tidal heating plays a significant role in the geology and evolution of many celestial bodies, particularly those orbiting close to massive planets. Io, another of Jupiter's moons, and the most volcanically active body in the solar system, owes its fiery nature to the intense tidal heating it experiences from Jupiter. While Amalthea's tidal heating is not as extreme as Io's, it is still significant enough to have influenced the moon's internal structure and potentially even its surface features. The heat generated by tidal forces could melt some of the ice within Amalthea, creating subsurface pockets of liquid water. These pockets, if they exist, could provide a potential habitat for microbial life, albeit one that would be extremely challenging to detect. By studying Amalthea's heat signature, scientists can learn about the efficiency of tidal heating, the distribution of heat within its interior, and the potential for liquid water beneath its surface. This information is crucial for understanding the habitability of icy moons and the potential for life beyond Earth. Section 3. A laboratory for radiation effects. Amalthea's orbit lies deep within Jupiter's intense radiation belts, a region of space teeming with charged particles trapped by the giant planet's magnetic field. This constant bombardment of radiation makes Amalthea a natural laboratory for studying the effects of radiation on celestial bodies and the processes that govern the interaction between radiation and planetary surfaces. The radiation environment around Jupiter is one of the harshest in the solar system. Charged particles, primarily electrons and protons, are accelerated to near-light speeds by Jupiter's rotating magnetic field, forming intense radiation belts that envelop the planet. Amalthea, orbiting within these belts, is constantly bombarded by these high-energy particles, which can penetrate its surface, altering its chemical composition and creating a variety of physical and chemical changes. One of the most noticeable effects of radiation on Amalthea is its distinctive reddish hue. Scientists believe that this coloration is due to the alteration of surface materials by radiation. High-energy particles can break down chemical bonds, creating new compounds and altering the way light interacts with the surface. Radiation can also create organic molecules, complex carbon-based compounds that are the building blocks of life as we know it. These molecules can form through the interaction of radiation with simple compounds like water ice, methane, and ammonia, which are thought to be present on Amalthea's surface. While the presence of organic molecules does not necessarily indicate life, it does highlight the complex chemistry that can occur in radiation-rich environments. Section 4. Future Exploration, Unlocking Amalthea's Mysteries. Despite its scientific significance, Amalthea remains a relatively unexplored world. Most of our knowledge about this enigmatic moon comes from telescopic observations and a handful of flyby images captured by spacecraft en route to other destinations in the Jovian system. To truly unlock Amalthea's secrets, a dedicated mission is needed. A future mission to Amalthea could involve a spacecraft orbiting the moon for an extended period, allowing for detailed mapping of its surface, measurements of its gravity field, and studies of its interaction with Jupiter's magnetosphere. A lander could also be deployed to the surface, providing in situ measurements of its composition, structure, and potential for harboring liquid water. Such a mission would provide invaluable insights into the formation of Jupiter's moon system, the processes that govern tidal heating, and the effects of radiation on celestial bodies. It could also shed light on the potential for Amalthea to harbor life, however unlikely that may seem. The exploration of Amalthea would not only advance our understanding of this enigmatic moon, but also contribute to our broader knowledge of planetary systems, the conditions necessary for life, and the evolution of the solar system as a whole. Amalthea, though small and often overlooked, holds the potential to revolutionize our understanding of the universe we inhabit. Section 1. Amalthea, a small world with big secrets. Amalthea, a small reddish moon dancing around Jupiter, may seem insignificant in the vastness of space. Yet, as we have seen, it holds within its battered surface a treasure trove of scientific knowledge. It is a time capsule from the early solar system, a testament to the powerful forces that shape planets and moons, and a laboratory for studying the effects of radiation and tidal heating. Discovered over a century ago, Amalthea continues to intrigue and challenge our understanding of planetary systems. Its irregular shape, sculpted by Jupiter's relentless gravitational embrace, speaks to the dynamic interplay between celestial bodies. Its vibrant red hue, a result of constant radiation bombardment, hints at the complex chemistry occurring on its surface. And its faint ring, a delicate halo of dust and debris, reveals the ongoing exchange of material between Amalthea and its surroundings. Amalthea's scientific importance extends beyond its individual characteristics. By studying this small moon, we gain insights into the formation of Jupiter and its moon system, the processes that govern tidal heating, and the effects of radiation on celestial bodies. These insights, in turn, contribute to our broader understanding of planetary systems, the conditions necessary for life, and the evolution of the solar system as a whole. Section 2. The Future Beckons. While we have gleaned much from telescopic observations and fleeting flybys, Amalthea remains a largely unexplored world. Its secrets, hidden beneath its battered surface and within its chaotic rotation, beckon us to delve deeper. Future missions, equipped with advanced instruments and driven by insatiable curiosity, hold the key to unlocking Amalthea's full potential. Imagine a spacecraft, specifically designed to study Amalthea, slipping into orbit around this enigmatic moon. It would map its surface in exquisite detail, revealing the intricate network of craters, ridges and plains that tell the story of its violent past. It would probe its interior, searching for signs of liquid water and unraveling the mysteries of its internal structure. And it would study its interaction with Jupiter's magnetosphere, unraveling the complex dance between magnetic fields, radiation, and planetary surfaces. The knowledge gained from such a mission would be invaluable. It would not only deepen our understanding of Amalthea itself, but also provide crucial insights into the evolution of planetary systems, the potential for life beyond Earth, and the fundamental processes that govern the cosmos. Amalthea, though small and seemingly insignificant, has the potential to revolutionize our understanding of the universe we inhabit. The future of Amalthea exploration is bright with promise. As our technology advances and our understanding of the universe grows, we can look forward to a time when this small reddish moon, once a mere speck of light in our telescopes, becomes a familiar destination in our exploration of the cosmos.